Homework 5 is on graphing logarithmic functions. So I'm actually going to start with one that's on the second page because I want to do one that has a couple of different transformations. So I've chosen number 6 to do for you guys. So this one has a base of 5. It's got a couple of transformations happening here. So remember with these ones, we start by looking at what the exponential function looks like, and then we turn it into its inverse. All right, so we've got the inverse function. So the inverse parent function, we're always just paying attention to the base. So the inverse parent function would be the exponential with base 5. So we can set up our little table using our classic values here. All right, so 5 raised to the negative second power, and you can always just sub these values into your calculator. So 5 to the negative second power is 1 over 5 squared. And that, whoops, sorry, my calculator is set to automatically give me, there we go. So 0.04 for this value. 5 to the negative first is the same as 1/5, which is 0.2. 5 to the 0 is 1. 5 to the first is 5. And 5 to the second is 25. All right, so you've got those values. That's not the logarithmic graph. That's the inverse of the logarithmic graph. So we start with our parent function, and then we're going to do the transformations. So the parent function is just log base 5. So the way that we set up this table is by just completely inverting this table right here. Okay, so by inverting, I mean taking the x values and y values and just swapping them. So as you guys get better at these, you could, the same way that I just made these my x values and sub them in here, you could just take these values and sub them in here to create your x coordinates. So rather than like officially writing down this table, if it makes sense to you to just jump right to this table, that is totally fine. All right, so now we have to make our transformations. So our transformations are going to be two things. This, the x minus 2, that means you're moving right 2 units. So we're going to move our whole table right 2 units. And then this minus 1 at the end is going to move us down 1 unit. Okay, so we'll set up one final table where we make those transformations. So moving everything to the right 2 units means that I add 2 to the x values. So 2.04, 2.2, 1 plus 2 is 3, 5 plus 2 is 7, and 25 plus 2 is 27. So those are my new x values. My y values move down 1, which means I subtract 1 from them. So this would be negative 3, negative 2, negative 1, 0, and 1. So I take these y values and subtract 1 from all of them. So these are the values that you're actually going to plot. Like all of these were just kind of steps in the process of getting these numbers. So these values get plotted. So we have an x value of 2.04, so basically 2, and then down to negative 3. 2.2, so just a little bit past, and then down to negative 2, so right about there. 3, and negative 1, 7 and 0, so 3, 4, 5, 6, 7 will be right at 0, and then 27, 1 would be way out here with a value of 1. All right, so we start there. We are also going to have a vertical asymptote with all of these logarithmic graphs, and it's the opposite. So if you have x minus 2, your vertical asymptote would be at positive 2 for my x values. So you can sketch in your asymptote there. All right, so with the asymptote, we kind of just skim right along that line until we start hitting points, and then our graph would look something like that. All right, so domain and range. This is one of the first sections that we've come across where the domain is actually not all reals, because you do have restrictions on what your x values can be, and you see this dotted line is like a fence that our x values cannot cross over. So notice that none of these x values at all are hit. This line represents an x value of 2, but nothing over here is hit at all. So you would say that your domain is just those x values that are bigger than 2. Not even or equal to, because it doesn't actually hit that line either. And then my range is all reals. Remember, when you create an inverse function, you swap all their x's and y's. So if the x's and y's swap, the domain and range swap. So normally for an exponential, the domain was all reals. When we swap them for the logarithmic, the range will now be all reals, whereas the domain has a restriction. All right, end behavior. So we have two arrows. Let's see. The graph goes up on this arrow right here. That is as x approaches infinity. That is as our graph goes off to the right here. And then the arrow goes down, so that would be this arrow right here. That arrow is going down as x approaches this dotted line, and that dotted line has a value of 2. All right, x-intercept is where our line crosses through the x-axis, and x-intercept has a y-coordinate of 0, so you can see off the table right here, that point has a y-coordinate of 0, so our x-intercept would be at 7, 0. And the asymptote this time is a vertical asymptote, so it's always an x equals line, and it's the opposite of this value in here. The whole graph shifted to the right 2 units, so our dotted line shifted to the right 2 units as well.